Okay, guys, I got a great video for you today. We're going to look at the Snake River and how it cuts through this area here. Now, this is a big mountain range it needs to cut through, and it does it. And this actually is a canyon that's quite a bit deeper than the Grand Canyon as far as vertical distance and depth. And I was researching this and I found an absolute gem of a video on YouTube. And it talks about how there is evidence that this current actually flowed the opposite direction. So currently it flows this way towards Washington. Okay. And then the Washington channeled scablands are here. But scientists are talking about how there's evidence that this current actually flowed in the opposite direction. Okay, so I'm going to play that video for you now. It's by a YouTube channel called School of Earth, Environment, and Society Seminar. So I'm going to play the video.
However, what geoscientists noticed early on was that there are these unusual features called barbed tributaries on the south side of Hell's Canyon. Barbed tributaries have been identified in lots of different places in the world as geomorphic indicators that a river may have flowed in the opposite direction to where it currently flows. So there's a couple creeks and tributaries that I've highlighted. There's Pine Creek, Indian Creek, and Wild Horse Creek. And based on their orientation, it looks like the Hells Canyon or the Snake River should be flowing south in this very specific region.
Okay, so let's look at a barbed feature here. This is how the tributaries normally form, and then because of the water current. So here's the arrow. The arrow is indicating a water current coming this way. And apparently that's what shapes these tributaries into that shape, which only makes sense if it's also underwater, right? So you have to increase the water level in order to get these tributaries orientated like this. And then once the current direction switches and now the arrow is on this side, it's then going to round out and streamline this. Streamline it here until this is the barbed. So the final result stage 3, we actually get the barbed shape. Now, another thing you could call this is a streamlined feature. Okay? Call it a barbed feature, or you could call it a streamlined feature. So she names 3 canyons: Pine Creek, Indian Creek, and I believe Wild Horse. And you can see how they're streamlined. So it doesn't really exactly look like this. It looks more like a streamlined feature. Right, so if you study aerodynamics, fluid dynamics, you're going to get a rounded shape here. And then what she doesn't mention is how the roundedness, or the I guess you could call it a barb shape, but it continues across. It's a perfect parabola. A parabola is something a parabola is something you find in aerodynamics. Right, so these aren't really barbed because if you look at these here, all of these are coming basically straight down. Doesn't have anything to do with that barbed thing. These are streamlined features. Now, if we go to, now we're in Greenland, right? This should be a glacially carved area, North Greenland. But we see river ruts here. We see these are formed from rivers. But they actually are coming up, right? And the reason we can tell they're coming up is because we can see the streamlined shape. Now, here it's streamlined, here it's streamlined. Now you might think, oh, well, maybe it's actually coming down this way. Maybe it's actually spilling from this direction. Well, this feature right here refutes that because it's a very nice streamlined feature here. Okay, and this is actually going uphill. Right, this would be the watershed boundary, or the divide of the watershed. Downhill from here, downhill from here. But this is showing uphill, right? So this canyon from this feature, this streamlined feature, and these other streamlined these other streamlined features, showing that water washed. You can assume probably both directions across this until it formed. And this streamlined feature here, this being in North Greenland, reminds me a lot of a spot in Canada. This is in our Ontario landscape. Shout out Geodoxia. They did the animation. This is their work here. Right, you can see how these are streamlined. Those are streamlined ruts. Then you get these features as well, which are streamlined features. That was actually a very famous spot, Kelly's Island. Kelly's Island in Ohio. Very famous spot for what do they call it? Glacier polish. No, this has nothing to do with the glacier when you're that streamlined and that intricate. Look how finely intricate all of these ruts and channels are. It has nothing to do with a heavy bulldozing glacier. So streamlined features. So this right here is a perfect example of this and this, right? Being streamlined, and even Indian Creek being streamlined. Now, and that's actually, the funny thing is, they think that these features are indications that the current actually went this way. No, that's not how a streamlined feature, it faces into, the front face faces the current. So this is actually not evidence of a current reversal. It's actually evidence of a very powerful current that swept over this. And when you look at this whole feature, this whole thing is carved out and circled around, right? So this had uplift, and then water went and circled around this. Okay, you think I'm probably talking crazy? Let me show you this then. So this is Mexico. Here we have the same thing. We have an uplifted feature. And then we also have it dug around, kind of a rut around it. We also have it being a terraced landscape. And then we also have current ruts. Okay. These are all ruts from sheet water flow. And they're parallel with the current. Okay, that's a feature we find all over the world. It's very common.